So again, what you want to do is, when you're trying to rearrange, always look at the carbon atoms that are attached to the carbon atom with the positive charge and see if there is a hydrogen or an alkyl group. A lot of times it's methyl groups or some other alkyl group that can move. Here's another example. Positive charge in a different spot. So whenever you see a carbocation, the first thing you want to do is ask yourself, is that primary, secondary, tertiary, methyl? What is it? This particular carbon atom has 1, 2 alkyl groups. There's a hydrogen on there that we're not showing. So it's got 1, 2 alkyl groups attached. That makes it secondary. If it's anything less than a tertiary, we want to shift something or try to shift something to stabilize it, to make it better. So in this case, we want to ask ourselves, is there anything we can move to turn it into a tertiary carbocation? To do that, we're going to look at the carbon atoms that are attached to the positively charged carbon. We're going to look over here, and we've got a couple of hydrogens over there. We're also going to look over here, because both of these are attached to the positively charged carbon. And here we have a methyl group and a hydrogen atom. So we have a few options here of what we could shift. We could shift a methyl group over to this carbon atom. And that would put shift a hydrogen over to this carbon atom. That would shift the positive charge over here. So instead of having a positive charge here, we'd have a positive charge over here. The molecule's not going to do that, because this positive charge in this spot would also be a secondary carbocation. So it's not making things any better. It's not making things worse, but it's not making anything better to move the hydrogen from here up to here. So there's no thermodynamic motivation for that kind of shift. So we're not going to do that. The molecule's not going to move one of these guys. Over here on this carbon atom, we have a methyl group that we could shift over to this particular spot. And that would put the positive charge over here. Remember that if we shifted the methyl group, it would be gone. It would be up here. And then again, the positive charge on that carbon atom would be secondary, which also isn't going to happen because that's not making anything better. It's still secondary. It's not any more stable. Last but not least, we have a hydrogen atom. We could move the hydrogen atom from this spot up to this spot, and if we did that, we'd put a positive charge down here. If we put a positive charge on this carbon atom, it would be tertiary, which is better than what we have, so that's what we're going to see the molecule do. We're going to move that hydrogen atom we're going to form a tertiary carbocation that is more stable. This is a concept that requires some practice. So I want you to do Skill Builder 6.3, and I want you to do problems 12, 13, and 30. And your study question, because we are going to spend more time in class once we start doing reactions. Remember that chapter 6 is kind of gearing you up for the stuff that's coming up in terms of reactions. As we start doing actual reactions, we're going to be spending a lot of time in class rearranging, shifting hydrogens, shifting methyl groups and alkyl groups and things like that. So this is something that we will come back to. It's not the end of this, but it is something that you want to be prepared for, so that when it does pop up in the content, you're a little bit familiar with it already. Your study questions for this section are, what is the relative stability of carbocations And when can a carbocation rearrange?